Howdy, this is Ms. Kosh. This is to all of my students learning trig. So this is going to apply to IB and it's going to apply to AP. So AP PreCal and IB Math, enjoy. Here we go. I teach it the same way in all these classes. And our goal today is to be able to fill out this piece of paper. So we need to know sine, cosine, tangent, cosecant, secant, and cotangent, the 6 trig parent functions. And you need to tell me the domain, the range, the period, the amplitude, and the asymptotes. I have already actually printed 175 copies of this because I have 169 students, and I'm going to make you complete this page in 6 minutes. So you'll graph one period for each of the functions and tell me all these things. And so I will post this page to you. I will post my answer key. Basically, you just have to know the parent functions, the trig parent functions, before we can continue. And we need that in all of the math courses that I teach. So be prepared for that, but I'm not going to just throw you out there and say, figure this out. I'm going to teach it to you. Oop, I'm playing at a wedding, and that's one of the songs they're doing. I forgot I just printed it. My bad. Okay, so, and there's my sub notes. Okay, let's see if we can just have what we need. So what I like to do is think in terms of graphing from sine and cosine. So you have already learned how to graph sine and cosine. You may know that the period, so with the sine and cosine, I want to see you label 5 things in a row, okay? And so it could be a 0, a max, a 0, a min, a 0. So you can label those. Let me see if I can zoom in. You can label those 5. You could have started here. I don't care. I just want 5 continuous, 5 in a row. On cosine, I might do the max, the 0, the min, the 0, the max. If I label those 5, you can label them with tick marks, or you can label them with ordered pairs. It's kind of small in here. So for example, the 0, 0, that one's obvious. You don't have to label that. But I do want to see that this is pi over 2, comma 1 is the first one. And then I have pi, comma 0. And I didn't save myself enough space. 3 pi over 2, commas, negative 1. Oh my goodness, it's first day back after Christmas break. And then this last point here is 2 pi, comma 0. That looks kind of terrible, so hopefully you can tell you remember what we're doing. But the important part here is that we need to know where the zeros are. And the zeros happen when x is equal to pi k, assuming that k is an integer. And so we've been writing k's a bit in all of my classes. So the domain is negative infinity to positive infinity. The range is negative 1 to positive 1. It includes those, so we use hard brackets. Cosine, now I should label these points, but it was kind of a disaster the previous one, so go look at the previous notes. But with both of these, when you graph one period for me, I want to see 5 things labeled. Okay, so 5 pieces of information. You could start kind of anywhere you want. I just need 5 in a row. Okay, so on this one, where are my zeros? Well, this first 0 is at 1 pi over 2. The next one is at 3 pi over 2. The next one was at 5 pi over 2. You may notice that they are pi units apart, so we'll say our zeros are at pi over 2 plus pi k. I wrote too big. K is an element of the integers, k's. My domain for cosine is the same as sine. It's negative infinity to positive infinity. My range is negative 1 to positive 1. The other thing that I didn't write down here, but you'll need in a minute, is the period, which is 2 pi, and the amplitude, which is 1, and that applies here and there. Okay, so that was a review, but we're going to use this when we learn to graph the other 4 trig functions. So you'll remember that cosecant is 1 over sine, that secant, and sometimes I've seen my students write, or actually I've seen in the IB world, so an international way of writing it might be cosecant like this. That's fine, I'm just lazy and I'm gonna write fewer letters if I can. I'm efficient. Okay, so cosecant is 1 over sine, secant is 1 over cosine, tangent we know to be sine over cosine, cotangent, cosine over sine. So if all of this is, if you're listening to me going, what are you talking about, then you need to go back and watch some of my previous videos. Okay, so we're gonna start by graphing cosecant, and we're going to write it in terms of sine and cosine. So this is 1 over sine of x. That's whatever. Okay, so when is it undefined? Well, you are not Chuck Norris. You cannot divide by 0. So cosecant will be undefined anywhere sine of x equals 0. Well, where does sine of x equal 0? We just wrote that down. Sine of x, here's sine of x equals 0 at pi k. So an x equals pi k. Well, what does it mean if it's undefined? It means either it's a whole or an asymptote, and nothing canceled, so it's not a whole, it's an asymptote. Where is cosecant 0? This is I'm trying to catch you. What's the right word? Yeah, anyway. It's a trick question. Oh my goodness. Okay, because the numerator, if I set this equal to 0, 1 cannot equal 0. So where is cosecant? Nowhere. Okay, so now what we're going to do is we're going to start by, I'm going to use, I couldn't find my blue and purple. I don't know. I need to get some new pins. We're going to start by sketching sine because this is the reciprocal of sine. My HL kids, that looks kind of terrible, but hopefully you know what sine's supposed to look like. My HL kids would remember that we graphed, one of the tricky transformations we did was where g of x was equal to 1 over f of x. Okay, and we're going to use those ideas. So what we want to think about here is anywhere I have a 0 in f, I'm going to be undefined. So I look at this graph and I'm going to put in asymptotes. There's one at 0. So this one, this is at negative pi. This one's at 0. This is at pi. Maybe I should write x equals, but I'm kind of out of space. This is at 2 pi. This asymptote is at 3 pi. Okay. Did I label this correctly? Oh yes, this is my axis. Okay. So what happens though is if I have 1 divided by something really, really small. If I take, I end up getting something really, really big. If I have 1 divided by something really, really big, I end up getting something really, really small. So as my graph, if I'm doing the reciprocal, and the other thing, here at 1, what is 1 divided by 1? Oh, you didn't see it, is 1. Okay, and so I'm going to graph cosecant in red. So here at 1, we're equal, I lied, this is pi over 2. But it has a y value, it has an output value of 1. And so as the sine gets smaller and smaller and smaller, cosecant gets bigger and bigger and bigger. And so it's going to do something like that. And then over here, if this were a negative 1 divided by 1, I lied. It's 1 divided by negative 1, but it's still negative 1. Okay, here we go. This one, as I get closer, as I get smaller and smaller and smaller, but negative, the reciprocal becomes bigger and bigger and bigger, but negative. And so it's doing something like this. And so I can keep doing these forever and ever if I wanted to. This line is messing with my head. Okay. So what happens, cosecant has the upward little, my kids would call these Lego hands, because do you remember playing with Legos and the toys, like they have their little, they look sort of like that. And so it would have this upward Lego hand and a downward Lego hand, and that would be 1 period. So this happened so notice from here to here is 0 to 2 pi. It would have to do, you have the upward part and the downward part, you need both of them, so the period is 2 pi. The asymptotes happen when sine had zeros, which was x equals pi k. K is an element of the integers. Okay, so my domain, we have infinitely many intervals. So either we have to write a rule for infinitely many intervals, which is not typically how we do this, or we're going to tell it it's going to be everything except my asymptotes. So I will use set notation, and I'll say it's the set x, such that x is not equal to my asymptotes, which were at pi k, where k was an element of the integers. Okay, what's my range? Well, notice my range, it went as low as 1 and then went up. It went as high as negative 1 and went down. So we're going to say, in this box I need more space. We're going to go from negative infinity to negative 1. We're going to include negative 1. Then we're going to pick it up here and go from 1 to infinity. I like to say, with this one, mind the gap. I did go to London last spring break, and I did hear the public transportation, the subway, say, mind the gap between the train and the platform. Anyway, but we have to mind the gap. There is a gap in our range right here. Okay, I think I'm funny. Okay, let's keep going. Oh, did I say everything? The period, the asymptotes. Notice on this one, if they ask for amplitude, we will tell them there is no amplitude. Okay, so we will say none. And if you remember back to this page that I'm making you do, sine and cosine have amplitude but no asymptotes. So you would write none for both of those. We would write asymptotes, none. Asymptotes, none. Okay, we just looked at cosecant, and we just found the amplitude. There is no amplitude. Okay, so here we go. Next one is secant. Okay, so secant is 1 over cosine, and that's going to behave in a very similar way to secant's going to behave in a very similar way to cosecant. However, things get shifted a little bit. So when is secant undefined? Whenever cosine of x equals 0. When did that happen? Oh, if only we wrote it down. Oh, wait, we did. Cosine has zeros at pi over 2 plus pi k. So what's going to happen here is that secant is undefined when x equals pi over 2 plus pi k. Pretend I wrote Kez. Okay, and then, so my asymptotes are going to be where those zeros are. X equals pi over 2 plus pi k. Technically, we should say k is an element of the integers. And, okay, so where is secant 0? Same idea from before. 1 cannot equal 0, so nowhere. Nowhere. Okay, whatever. However you want to answer that question. Okay, so let's come back here, and what you can do to graph this one is start with cosine. If you remember, cosine is something like this. Okay, that line is going to mess with my head again. And we're going to have zeros. Where cosine has zeros, we're going to have asymptotes, is what I intended to say. This first positive one is pi over 2. The second positive one is 3 pi over 2. The third positive one is 5 pi over 2. The first negative one is negative pi over 2. That's a negative. Can you see it? I lost my negative sign. Okay, and then same exact idea, except now we've got the point 0, 1, and then this is pi, negative 1, and we're going something like that. Okay, I forgot to tell you what I'm looking for with secant and cosecant. I want 5 pieces of information. Okay, so I want it to be labeled very clearly, and maybe we need more space, but I want it labeled clearly. Either you can go asymptote, this is a minimum, asymptote, maximum, asymptote. So that was 3 asymptotes, a minimum, and a maximum. That's 5 pieces of information. Or you could start at this minimum and go minimum, asymptote, maximum. It's a local min, an asymptote, a local max, an asymptote, a local min again. So you could do 5 in a row. Same idea here. I would want 5 things labeled. So you can either do 2 extrema and 3 asymptotes, or you can do 3 extrema and 2 asymptotes. Did that make sense? Hopefully it did. We'll talk about it again in class. So the period is how long does it take it to do everything it's going to do? Well, basically we need 2 sets of Lego hands again. So if we go from negative pi over 2 to 3 pi over 2, we have gone a distance there of 2 pi. Or you could think, here I'm starting at 0. Where do I get to do that little piece again? It's at 2 pi right here. I should label that. But okay, so the domain is the set x such that x is not equal to my asymptotes. Pi over 2, oh, I forgot, I put the comma too soon, plus pi k, ignore that, comma, Kez. The good news is the range matches what we saw a minute ago. We have to mind the gap. And we'll say negative infinity to negative 1, pick it up again, 1 to infinity. And there's the domain and range for secant. And remember, does it have amplitude? No, it has no amplitude. So what would you do on this lovely little page where it says secant and it says amplitude? You would tell me none. Okay. So far you've noticed we've written the word none 4 times. We're not finished. We're going to write it 6 times. If you miss that, well, I'll be a little frustrated because. Okay, that means you didn't study, and you need to study. Okay, moving on to tangent. Okay, so tangent is sine of x over cosine of x. And so when is tangent undefined? Well, whenever cosine of x equals 0, which was pi over 2 plus pi k, we can look back to that first chart right over here if we need to. Where is tangent 0? When my numerator is 0. At this time, my numerator can equal 0. This is a fraction. And so where is tangent 0? When sine of x equals 0, which is when x is equal to pi k. Okay, so that means when I graph this, I have a 0 at 0. I have an asymptote at pi over 2. I have a 0 at pi. I have an asymptote at 3 pi over 2. I have an asymptote at negative pi over 2, and I can keep going. Okay, now what's going to happen, we're going to think in terms of the unit circle for a second. On my unit circle, tangent is positive, negative, positive, negative. Okay, this is 0, this is pi over 2, this is pi, this is 3 pi over 2. If I'm going too fast, it means you need to go back and catch my previous videos. And so here, from 0 to pi over 2, we have positive values. So we're going to be increasing here, approaching that asymptote. Then from pi over 2 to pi, we are negative, and so it's kind of shaped this way. So the zeros are our points of inflection, you'll notice. Make sure, and then from pi to 3 pi over 2, we are positive, so our numbers go something like this. You'll notice I am not overly concerned about putting them in the exact right spot. So anyway, there we go. The easy one to work with is pi over 4, gives us a y value, an output value of 1, but I don't always care that we label that. So on tangent and then also cotangent, I'm looking for 3 things. Either I want an inflection point, an asymptote, an inflection point, or asymptote, inflection point, asymptote. Okay, so those are the 3 things I want labeled. So my period, this one though, does everything it needs to do. It repeats every pi units. Notice so the first 4 that we looked at, sine, cosine, secant, cosecant, all had a parent function period of 2 pi, but tangent's parent function has a period of pi. The asymptotes occurred where the zeros were, pi over 2 plus pi k. K is an element of the integers, so therefore the domain is going to be the set x such that x is not equal to pi over 2 plus pi k, okay, and now our range for tangent is pretty easy. It's just all real numbers. Okay, cotangent, let me switch colors so maybe we can see what I'm doing on this next one. This piece of paper is, oh, by the way, does tangent have amplitude? No, tangent does not have amplitude. So when you come back to this page, you're going to tell me amplitude, you're going to tell me none. Okay, where were we? Here cotangent is going to be cosine x over sine of x. So where is it undefined? Whenever sine equals 0, which is pi k. Whereas cotangent 0 whenever cosine of x is equal to 0, which was pi over 2 plus pi k. Okay, and so we're going to work in a similar fashion to what we did with tangent, but now what was an asymptote becomes a 0, what was a 0 becomes an asymptote. So we're going to have an asymptote at 0, we're going to have a 0 at pi over 2, we're going to have an asymptote at pi, this was pi over 2, we're going to have a 0 at 3 pi over 2, we're going to have an asymptote at 2 pi, we're going to have an asymptote at negative pi. We're going to have a 0 at negative pi over 2. Okay, and so now let's think back to our unit circle. Tangent and cotangent are reciprocals. Now, if I take tangent and I flip it over, does that change it from positive to negative? Well, you can't answer me, but the answer is no. It doesn't change it. So cotangent here will be positive, negative, just like tangent was, because all we did is took the value and flipped it. Okay, so from 0 to pi over 2, we're positive. Here's 0, here's pi over 2. So we need positive values, which means that we it's a decreasing function here. Okay, and now from pi over 2 to pi over 2 to pi, we're negative, and so it's a similar shape, but it's cotangent ends up being the graph of tangent, but reflected and shifted. Okay, but it looks something like this. Yep. I shouldn't have crossed that asymptote, but whatever. Okay, this one, once again, its period, it lives between these 2 asymptotes. Its period is pi. The asymptotes were at x equals pi k. K is an element of the integers. Therefore, the domain is everything except the asymptotes, x such that x is not equal to pi k. And just like tangent, the range is negative infinity to positive infinity. And what am I looking for with tangent and cotangent? You have to show me 3 things. You have to show me 1, 2, 3. You have to label those 3 things. Or you could say 1, 2, 3, but this one's just nice to go from asymptote to 0 to an asymptote. Okay, so on this, does cotangent have amplitude? No, it does not. So back on this page, when it says cotangent and it's going to ask for amplitude, you're going to tell me none. The short answer is either you have amplitude or you have asymptotes. You won't have both. Okay, so cotangent, I'm looking for 3 things to be labeled. 1, 2, 3. Tangent, I'm looking for 3 things. 1, I didn't graph it. Here's the graph. So that would give you full credit. My answer key may have more than one period because sometimes it helps for me to have a little bit more so I can grade yours faster if you gave a different period than I gave. And I should label, this is pi over 2, and this is pi, and this is 0. If you don't label the 0, that's not the end of the world, but these two need to be labeled. This one would be here. So you would say negative pi over 2. I'd want to see that labeled. You tell me pi over 2, and then that's obviously 0. And so we're looking something like that. So these two, you can only give me, you only have to label 3 things, but the other 4, I need to see 5 pieces of information labeled. All right, go practice. This is going to be critical for the rest of the year that you know how to graph all these lovely trig functions. All right, good luck.